Alright, so today we are going to do 5.3, proving triangles are congruent by SAS. SAS is side angle side. So if two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So if we have triangle ABC and DEF, that means that if the side length AB is congruent to side length DE, and if the angle ABC is congruent to angle DEF, and if BC is congruent to EF, then the triangle ABC is congruent to the triangle DEF. So the included angle means the angle between the sides. So the angle in between the two sides, that's the included angle. So for our next couple examples, we want to state whether the triangles can be proven congruent and, if possible, by SAS, so side angle side. Include a congruency statement for all congruent triangles. So for number one, the little tick marks again tell us which sides are congruent, and then the little half circle in the corner means that those angles are congruent. So we do have side angle side here. So these triangles are congruent. So triangle TQY is congruent to triangle PCY. Okay, let's look at number two. Number two, we're looking at the two sides. Those are congruent. The angle is congruent. However, the angle is not included. So it's not in the middle of the two sides. So we don't have enough information here to tell whether or not these triangles are congruent. Okay. Number three, we do know that the sides are congruent, and we have that angle in the middle. So those angles are vertical angles, and hopefully you remember that vertical angles are congruent. So since we have the angle included between the two sides, yes, triangle ACB is congruent to triangle ECD. Okay, last one. These little signs right here, that means that these two sides are parallel. They're congruent and they're parallel. So keep that in mind as well. So we have this side, we have this side, and this side. And then those are congruent based off of their little tick marks. We know that vertical angles are always going to be congruent triangles, or congruent angles. And so this is these are congruent triangles. And the way we know that is if these angles are the same, these lines are parallel, then we know that this angle is the same as this angle. So those two angles are congruent because those lines are parallel. Okay? So let's move on to some proofs. So before we start, we know we're given that JM is congruent to LN. Okay, so I'm just going to mark that on our on our little figure to the right there. And then we also know that angle JMN is congruent to LNM. Okay, so if we know that, then we also know that this line in between is congruent. So we have that sign, and we also have these angles. So JMN, so right here, and LNM right here, those are congruent angles. Okay, so then this first one, remember, is always going to be given. So since this is a side length, this is one of our sides. Okay, now we're looking at angle JMN and angle LNM. this is also given to us, and this is our angle. Okay, now we're looking at the side length MN is congruent to NM. We know that because it's the reflexive property. Okay, and then this last one, JMN, is congruent to triangle LMN. This is because of the side angle side congruence. Okay, now let's keep going. So we have, for number 6, we have a little triangle, so ABD and CBD, and we want to know if those are congruent triangles. So we know that AB is congruent to CB, and BD bisects angle ABC. So therefore, those angles are up top are congruent because they're bisected, and that line in the middle, it's congruent on both sides for the triangles. Okay, so the first one is given to us as always, and the second one, BD bisects our angle ABC, is also given to us. We know that already. So we have our side, and we have our we almost have our angle. We have, for this next one, angle ABD is congruent to angle CBD. And for this one, this is the definition of an angle bisector because it's being bisected, right? So we know that they're equal because they're bisected, okay? And then BD is congruent to BD. Again, we know that because it's the reflexive property, and that is our final side. And then we know that these two triangles are congruent because of side angle side triangle congruence. Okay, so now if we're looking at 7, V is the midpoint of WZ and XY. Okay, so V is the midpoint. Right here is the midpoint. So that means that those two segments are congruent, and XV and VY are also congruent. Okay, so this first one, V is the midpoint of WZ and XY. That's given to us as always. And the second one, WV is congruent to ZV, is because it is the definition of midpoint. And then the angle of WVX is congruent to angle ZVY. This is because they're vertical angles. And then the length XV is congruent to YV, and that's again because definition of midpoint, and that's our frontal side. So we have SAS there. And because we've shown the side angle and the side are all congruent, we know that those two triangles are congruent. So SAS congruence theorem. All right, so what I want you to do is try this next one on your own, see what you come up with. All right, so hopefully you paused the video and you found that the side length HI is congruent to JG, sorry, that's really hard to say, and HI is also parallel to GJ. So you can put in your little markings here. So remember that arrow means that those are parallel. So those are parallel. That length is congruent right there because of the reflexive property. So we know that those angles on the outside are congruent. Hopefully you remember why, if they're cut by a transversal. And then, so HI is congruent to JG. This is given to us. And then the next statement as well is given to us because they are both, they're parallel lines. And then we know that GJH is congruent to IHJ. And this is because they are alternate interior angles. So hopefully you remember this from a while ago, but they are alternate interior angles. So they're cut by a transversal alternate interior. Okay. And then HJ is congruent to JH. This is again because of the reflexive property. And then the two triangles are congruent because of side angle side congruence.